Yes, welcome to today's on modern physics. This is one of the key topic for UPS NDA, NCET, IIT, JEE, AMCET, CUET, EAPCET. So without wasting your time, I would like to start the concept with your permission. Thank you. I'm not taking the entire lecture, just I'm going with the key concept revision. Then after we will go with the 75 MCQs for your examination point of view. So here what is atomic mass? Atomic mass is total mass of an atom. Atom is nothing but a smallest particle which is indivisible according to Mr. Dalton. Total mass, that is proton, neutron and electron. Positive charged particle, negative charged particle, neutral charged particle. So total mass of an atom, that is sum of proton, neutron, electron, is known as atomic mass, measured in atomic units. Atomic mass unit AMU. The actual nuclear mass is slightly less than the sum of individual nuclear masses. Nuclear masses, that is called as mass defect. For example, we have hydrogen. In a hydrogen we have one proton, one neutron. So here, based on that one, we will consider here the mass of proton is approximately, I am taking that one, 1.0087. Mass of proton is 1.0078. So here the mass of hydrogen, if I take 2, then this value it is more than 2. The actual mass of the hydrogen is how much? 2. But here it is about more than 2. So these differences we will consider as mass defect. That is the difference between parent nuclei to daughter nuclei mass is known as mass defect. Here we have one example also, the given to you. So this is the actual mass of the hydrogen, 2.014. Here 2.016. So this difference we called as mass defect. If you multiply mass defect with the mc square, that is called as binding energy. Okay, what is binding energy? Binding energy is the energy equivalent of the mass defect, that is delta mc square. This is called as, see, delta M is nothing but what? Mass defect. Mass defect with the c square. This is known as the binding energy, representing the energy needed to separate the nucleus into individual proton and neutron. So individual proton and neutron, to separate as individual proton and neutron, you need a energy, and that energy is called as binding energy. Higher binding energy per nucleon is greater stability. The element which is having more binding energy, and that is nothing but greater stability. It is having great stability. Okay, binding energy is, that is, we can see also here, binding energy is of a nucleon. Energy required to combine individual protons or separate individual proton and neutron into a nucleus or out of the nucleus is known as binding energy. Some of the mass of protons and neutrons is lost to create the binding energy following Einstein equation equal to mc square. This is where mass defect goes. When energy is converted, that time energy will be losing, so that we are nothing but binding energy. Why we have differences? Because of during the energy transmission we will see the energy loss. So that is about the mass defect as well as binding energy concept. You can see here binding energy formula, that is delta M into c square, where one atomic mass equal to, that is about 931.5 million electron volt per c square. What is nuclear fission? Nuclear fission is the splitting of heavy nucleus into to lighter nuclei is known as the nuclear fusion. For example, you can take the uranium. Uranium is bombarded by a small neutron. Then it is split into barium, krypton. It is split. Uranium is bombarded by neutron. Then it is split into barium and krypton. It also at the same time releasing 3 more neutrons. That is known at the same time energy also. Sorry. So uranium is a heavy element. It is bombarded by a small neutron, then split into lighter nuclei like barium and krypton by producing 3 more extra neutrons that along with the energy association that is called a nuclear fission. Fusion, combination. So here this is responsible for solar energy. It is responsible because of the fusion. So solar from the sun we were getting sunlight, that is about the fusion reaction. In fusion what will have? Nuclear fusion is the combining of lighter nuclei. Lighter nuclei like hydrogen will give rise to helium. So this is about the nuclear fusion. Lighter nucleus will give heavy nucleus, that is about the nuclear fusion. Because of this character here today we are receiving sunlight, that is about the nuclear fusion, which is opposite phenomenon of fission. Subatomic particles. What are the subatomic particles? Inside atom we have subatomic particle like proton, neutron, electron. Proton is a positive charge, neutron is a zero charge, electron is a negative charge. Okay, clear? Understood? So proton positive, neutron zero charge, electron is negative charge. Where we have proton and neutron inside the atom. Inside the atom, proton and neutron. Outside this nucleus, we have negative charged electron. This negative charged electron is revolving around a nucleus. This is a graphical representation of proton, neutron, and electron. Here, proton and neutron inside. So this is about the nucleus. Outside of the nucleus, so the negative charged particle is revolving around a nucleus. Cathode ray tube, CR2 experiment. See here how we got these particles. That is the reason we have some experimental history. J.J. Thomson used a CRT. CRT means what? Cathode ray tube. To discover the electrons. How electrons are discovered? Electrons are discovered by the J.J. Thomson, but before that one he done one experiment that is called the CRT experiment, which is nothing but cathode ray tube experiment. High voltage produces cathode rays. That is nothing but electron beam, and that are deflected by electric and magnetic field. These electrons, that cathode rays are deflected by electric field and magnetic field, which are produced by high voltage. I proving that one they have negative charge and small mass, and that defined as cathode ray. Cathode ray again named as electron because of a deflecting character. Okay, clear? Cathode rays for streams of electron, which is nothing but negative charges. Next one, anode rays. Positive ions or protons is known as anode. So this is the experimental setup how done by Mr. Thomson. Next, atomic models. What is atomic model? How atoms consist of proton, neutron, electron. How these electrons are embodied, protons are embodied, neutrons are embodied inside the atom. To define that characteristic, there is a visual representation we have, and that is proposed by the Thomson, Rutherford, and Bohr, and they are known as atomic model. We have Thomson proposed plum pudding model, just like a watermelon character. Rutherford proposed planetary model, and Bohr is proposed that orbital character model. So here Thomson proposed plum pudding model. So that is about a positive sphere with embodied electron, just like watermelon. That is about plum pudding model. Rutherford, dense positive nucleus with the orbiting electrons. That is nothing but alpha particle scattering. Bohr, electrons are in fixed orbit with the quantized energy, which is against the classical physics. So here history of the atoms. So here you can see Dalton proposed that is solid sphere model in the year 1803. In 1904, Thomson proposed plum pudding model. In 1911, Rutherford proposed nuclear model. This is wrong assumption. Bohr is proposed is planned. This is similar character, but this is a modification. And quantum model proposed by the Okay, clear? Okay, this is correct only. Nuclear planetary model, how the planets are evolving. This is nuclear model. Okay, now how the electrons are embedded at the outside. This is about the positive charges matter. In the positive charge matter, electrons are embedded. Isotopes, isobars, isotopes, isoelectrons. What is that? Isotopes, they have same protons. Example, carbon and carbon, 12 and 14. Carbon 6 12, carbon 6 14. Here the atomic number is same. So that this is called isotope. Same atomic number, different mass number, same element, that is known as isotope. 1H1, 1H2, 1H3. Hydrogen, deuterium, tritium. See, same atomic number, different mass number. So this is also one of the example for the isotope. Isobar, they have same mass number. You can see carbon 6 14, nitrogen 7 14, 14 14. Mass number is same, atomic number is different and different elements. So this is called isobar. I know I am not taking lecture, I am just going with the key points because we have 75 MCQs I have to cover. I am not taking entire chapter because you know these are all topics. That is just I am taking key concept as a revision, just as a revision. Isotopes. What is isotope? They have nothing but same number of neutrons. They have same number of neutrons, that is about the isotopes. What is isoelectronic? They have same number of electrons, so that is about the isoelectronic. That means you can take sodium neon. Sorry. You have neon. Sodium is 11 and sodium plus is about 10, neon is 10. So neon Na plus, they have same number of electrons, so that is about isoelectronic. Electromagnetic radiations. Electromagnetic spectra include radio waves to gamma rays. Radio waves to gamma rays, all are traveling with the speed of 310.8 meter per second. So energy, that is energy is always proportional to the frequency. When you remove the proportionality, E equal to H nu. So this is about the electromagnetic radiation. Electromagnetic spectrum is nothing but group of frequencies: gamma rays, X rays, UV, visible, IR, infrared, microwaves and radio waves. So frequency is higher. While you are moving from gamma to radio waves, wavelength is increasing. When you are moving from gamma to radio waves, frequency is decreasing. Highest frequency for the gamma rays, highest radiation, highest wavelength for the radio waves. Radio decay, radioactive decay. Radioactive decay is nothing but, see, when element, when we are placing in external field, it is gradually reducing size. The lifetime is reducing, the size is reducing, and that we call as the decay. And this decay we consider as alpha decay. Reduction, decay means beta and gamma. In alpha decay, when you are taking for example a sample, for example this element is having atomic number is Z, mass number is A. In alpha decay, its atomic number is reduced by 2, mass number is reduced by 4. Similarly beta, atomic number, if you are taking Z and A, mass number remain as it is, but atomic number increased by 1. In gamma, no increasing in atomic number, no increasing in mass number, that is about the gamma. So here emits helium-4 nucleus, low penetration, so it is double ionized helium, is nothing but alpha particle. Beta emits by the electron, neutron is converted to proton. Then gamma, high energy, that means it is having high frequency, so that is the reason it is about the high penetration. You can see here gamma rays can transmit it through paper, aluminum, lead, but beta it is restricted to here, alpha only paper. That is the reason alpha is having high ionization where gamma is low ionization. But coming to penetration, that means striking property, alpha is the least, gamma is high. Okay, clear? So see, you can see alpha particle how it is moving, shifting in the presence of the electric field, external electric field, which are moving to the left side, that is called alpha, which are moving to the right side, they are called as the beta, which are nothing, they are moving straight way, that is called as gamma. Radioactive series nuclear transmutation. So radioactive series uranium involved in sequential alpha, beta, gamma ending with stable element. Uranium undergo 14 different radioactive decays and passes before forming a lead element. 14 different radioactive decay. Uranium 238 decay series is a stark vector. Sorry, this is a brown. Uranium 238 undergo 14 radioactive decay and ending at lead. So uranium will be transmitted to lead. What is transmutation? Artificial conversion of one element to another via particle bombardment, like nitrogen is converted to oxygen. This is called as artificial transmutation, which is introduced by Rutherford. So you can see here uranium 238 after undergoing lot of radioactive decays, it is settled at lead. That means this unstable element of uranium 238 after undergoing different radioactive decay and stable at lead 206. Applications of radioisotope artificial radioactivity. So you can take iodine 131 used in treatment of thyroid, cobalt 60 used in cancer therapy, and they are not only used in medicine, they are also used in industry like thickness gauging tracing, and C14 used for the archaeological samples to detect the fossil edges. Artificial radioactivity induced bombarding stable nuclei with particles. So this artificial radioactivity, it is discovered by Marie Curie and Frederick Joliot. So first question, we start with it. Okay, that just revision. I am not taking entire class. Just a given key concept. Now we go for the MCQ series. The mass defect in nucleus is due to, for what? So the mass defect in nucleus is due to loss of mass during the formation, conversion of mass into energy, difference in proton and neutron mass, electron in binding. So here the answer is that is conversion of mass into energy, E equal to mc square according to Einstein mass energy theorem. That's about energy mass defect occur. Mass defect is converted into binding energy via E equal to mc square, holding the nucleus together. So what is mass defect and what is binding energy? We clear. Mass defect is nothing but the differences between parent nuclei to daughter nuclei mass is called as mass defect. So if you multiply mass defect with the c square, then that is called as binding energy. So here what is binding energy? The binding energy of a nucleus is energy required to combine individual protons and neutrons into a nucleus. See, to bind proton and neutron, we need a energy, and that energy is called as binding energy. Book binding, papers are we are bind together, that is called book binding. Similar way, proton and neutrons are bind together, that energy is called binding energy. So binding energy is equal to mc square, that is binding energy is equal to mc square. So here we have an example that is about before carbon. You can take carbon atomic number is 6, its mass number is atomic number is 6 and mass number is 12, and before that one carbon is having 6 protons and 6 neutrons. So here 6 into proton value, 6 into neutron value, then the value of the mass before, that is about the 12.095. After the taking individuals mass of the proton and neutron, you will get, so this is original mass of the carbon, that is about the 12. This is called parent nuclei mass. Now daughter nuclei, there are 6 protons and 6 neutrons. If you calculate, you will get 12.09. You will get 0.09. Is it right? This 0.09 we called as mass defect. If you multiply with the c square, that is called binding energy. What is that one? Binding energy. Coming to second one, binding energy per nucleon is maximum. For whom it is maximum? So here we have a series binding curve in class 12. So that is like that, we have a curve. So the binding energy maximum for whom? The binding energy maximum for, that is about the, binding energy maximum for whom, that is about, you will see this type of the curve in the class 12 textbook. Binding energy per nucleon is maximum for which, that is about the iron, that is about 56. So binding energy per nucleon peak is maximum for the iron. Okay, clear? That is indicating that it is a stable one. In nuclear fission uranium-235, the number of neutrons are released typically. How many neutrons will be released? That is, in nuclear fission, 2 to 3. Most probably 3 neutrons will be released. Averagely 2.5 neutrons for fission. So your answer is 2.B. Coming to third one, fourth one, the source of solar energy. Source of energy is nothing but fission, nuclear fusion, chemical bonding, gravitational contraction. So your answer is, here hydrogen will give rise to the helium, where it is nothing but nuclear fusion reaction. Fifth one, cathode rays are what? So cathode rays are discovered by J.J. Thomson by using of the particular set of, that is nothing but CRT, cathode ray tube experiment. So here cathode rays are nothing but negatively charged electrons which are deflected by electric field and magnetic field. I am not giving all explanations for the other option because it will take consuming time, time killing. So that's why I am directly explaining the answer. Sorry if you are any what we call, if you are any discomfort, sorry. Okay, that is cathode rays are negative charged electrons. So cathode rays are deflected by, that is about the electric field towards the positive. Sixth one, in Thomson-Plum pudding model, the atom is, so here not empty, not planetary system wavelength. It is uniform positive charge with embedded electrons. So you can see the figure. So the answer is, it is about B, uniform positive charge with embedded electrons. Fail to explain Rutherford scattering. Okay, clear? Rutherford experiment showed that, what shows? Rutherford experiment shows that one, atom is indivisible, electrons have fixed orbit, neutrons exist. So Rutherford experiment showed that one, positive charge is concentrated in small nucleus. So that is B. Most of the alpha particles are passed undeflected, few scattered at large angles. So only one is bounced back. If you pass 10,000, 9,999 are deflected, only 1 out of 10,000 are bounced back because of the small nucleus. So here positive charge is concentrated in small nucleus. Bohr's model is introduced. Bohr's model is introduced to quantized energy levels, not wave nature, not nuclear structure, not relativity. Bohr's model introduced to quantized energy levels, explained hydrogen spectrum, not explain multi-electrons for atom. Only is for hydrogen, helium +1, lithium +2, monoatomic elements. And others it is failed. Ninth one, isotopes have same atomic number, different mass number, like 1H1, 1H2, 1H3. Same atomic number, different mass number. Isoelectronics, they have same electrons, like this is 6, sorry, this is 10, this is 10, this is 10, 10, so they have 10 electrons. Electromagnetic radiation with the highest frequency, so highest gamma to radio waves, wavelength is increasing, frequency is decreasing, so highest frequency is for gamma rays. Okay, then you can see here radio waves have least frequency, gamma rays have high frequency. You can see gamma frequency, this is about the wavelength, this is about the frequency, wavelength minimum, wavelength is maximum. 12th one, alpha particles are what? Alpha particles are helium nuclei. Double ionized helium nuclei is known as alpha particle, even though they are stopped by paper. Beta decay is, when beta decays occur, then that atomic number is increased by 1. Mass number is remains same. So here the uranium decay series ends at, so uranium decay, you can see here mass number, atomic number, so here that is end at lead, the stable element. Artificial radioactivity was discovered by artificial radio, that is Madame Curie, Frederick Joliet. So bombarding aluminum with alpha particle, not AI, alpha particle, aluminum with the alpha particle produces radioactive phosphorus. So that is about Curie and Frederick Joliet. Coming to 16th one, the phenomena response for the blue glow in cathode ray tube. So that is about fluorescence and ionized gas. Fluorescence and ionized gas, you can see here, and this blue gas is comes because effect of the fluorescence and ionized gas. So cathode rays causes fluorescence on glass, ionized residual means remaining gas produces the characteristic glow. In Rutherford 71, in Rutherford's alpha particle scattering experiment, most alpha particle pass straight through the file because that is about the atom is mostly empty, only one is bounce back. So your answer is A. The limitations of Bohr atomic model that it fails to explain why it is failed. So that is about it is spectra of multiple electrons. It is valid for only monoatomic like hydrogen. Bohr model works well only for hydrogen like atoms. It cannot account for more electron interaction in complex atoms. So your answer is it is failed to explain spectra of multiple electron orbit. Yeah, 19th one, isotopes are used are nuclei having the same number of neutrons. The limitations, okay, sorry. That is our same number of neutrons. Coming to 20, right? Which radiation has the highest penetrating power? That is about, see, this is about the ionization. So the highest penetration power, sorry, this is the penetration power. Even alpha particle will be stopped by the paper, but gamma rays even they can be moved through lead also. So the highest penetration power is for the gamma. Alpha decay, the atomic number of, so alpha, when we have JEE, in alpha decay, atomic number is reduced, mass number is reduced by 4. So here atomic number, the question is asking atomic number, so decreased by 2. Beta decay increases the atomic by 1 because what we have, a neutron is converted into proton, y plus 1 in beta decay, atomic number y plus 1, that is neutron is converted to proton. The end product of uranium radioactive series, that is about lead 206, lead 206, you have to see, not 7, not 8, it is about lead, that is 206. 24. Artificial radioactivity was first discovered by, that is about Curie and Joliet. So that is, they produce radioactive parcel by bombarding aluminum with aluminum plus alpha will give phosphorus. This is about the artificial radioactivity. Aluminum 1427, helium 24 will give rise to phosphorus 1530 and neutron. Which of the following is an application of radioisotopes in medicine? That is about medicine in thyroid diagnosis, in cancer radiotherapy we are using cobalt and iodine. Iodine 131, cobalt 60 we are using in medicine. Phosphorus we are using in agriculture, not medicine. Which of the following is an example? Which of the following is an application of radioisotope in medicine? That is 25th question. So here already it is repeated. Sorry. So that is about the iodine 131 and cobalt 60. 36 one. The binding energy per nucleon is maximum near mass number. That is about iron, which is about the 56. Nuclear fusion is a source of energy in what? It is source of energy in sun and stars. Helium will convert to the hydrogen will convert to the helium 24. This is about the nuclear fusion. Okay, clear? So that is about source of star and sun. In nuclear fusion, the energy released due to mass defect, increase in binding energy, conversion of mass and energy, mass into energy. 29th, the electromagnetic radiation used in radar. Which electromagnetic, not radio waves beta, electromagnetic waves are used in radar, that is microwaves. Make sure that is microwaves are suitable wavelength to detecting ranging, for detection and ranging. Coming to 30, which particle was discovered using cathode ray? That is about the electron. CR2 experiment. CRT. Thomson-Plum-Poling model could not explain. Why it could not explain? It could not explain large angle scattering. It is for only for small angle scattering. That is the reason it failed in Rutherford experiment. Thomson-Plum-Poling model could not explain large angle scattering. Isoelectron species have identical electrons, same number of. The order of ionization energy power, that is gamma is greater, ionized are not penetrating, alpha having highest, then beta, then gamma. Coming to penetration, gamma greater than beta, beta is greater than alpha. Okay, coming to radioactive decay series, the change in mass number after 1 alpha to beta. 1 alpha to beta. So here you can take one element, that is X, A, Z, 1 alpha. What is happening? Z is reduced by 2. This is reduced by 4. Next, beta. Beta A is as it is. Am I right? Mass number. This is changed to plus 1. So Z plus 1. So now tell me. So that is alpha decreases by 4. Beta does not decrease by 4. Your question, in the radioactive decay series, the change in mass number after, change in mass number, so that is mass number only asking, so that is about reduced by 4. Nuclear transmutation is the process of, see, nitrogen, whenever it is bombarded by helium, nitrogen convert to oxygen. Nitrogen changes to oxygen. This is called as artificial transmutation. This is discovered by Rutherford. So nuclear transmutation is a process of artificial conversion of one element into another. 36 one. The main source of solar energy is the fusion reaction. That is 1H4 is converted to helium-24 plus releasing 2 electrons and energy. So that is about, this is the correct, this is not, so this is right answer. Gamma rays are produced by a nuclear returns from excited ground state or alpha beta decay occurs. So gamma rays are produced by emission of the excited electron to the ground state in return form, then alpha beta decay. So gamma rays emission often accompanied by alpha beta to release excess of nuclear energy. The half-life of a radioactive substance is independent of what? It is independent of temperature, pressure, amount of substance. So nothing is depend. It is only depend by dN by dt, gamma. So here temperature, pressure, amount of substance, these are not valid. Half-life is a characteristic constant. It is a characteristic constant of isotope. 39th one, which of the following is not a property of electromagnetic radiation? So electromagnetic, their speed, the travel is the speed of light, that is right. And they shows interference, this is right. They carry energy and momentum, that they are deflected by electric field. So a question is negative asking. Electromagnetic waves are not deflected by electric field. Electromagnetic waves are uncharged and unaffected by electromagnetic field. Electric and magnetic field are uncharged in EM waves. EM wave is uncharged by due to electric and magnetic field. The E by M ratio of the cathode rays, the E by M ratio for cathode ray is what? It is same for all gases. Same for all gases. Okay, cathode rays are always electrons independent of gas used. Rutherford model is failed to explain what? It is failed to explain stability of atom, discrete line spectrum. It explains nuclear size, which measure. Okay, it is failed to explain stability of atom, discrete energy, discrete line spectra. Classical electromagnetism predict electrons should spiral into the nucleus. Electrons should revolve around the nucleus. Okay. That is 42. Isobars have the same, what they have? Isobars have same mass number, like carbon, carbon 6, 14, nitrogen 7, 14. So they have same mass number. The most penetrating radiation among the following is what? So that is about gamma rays. 44th one, the Uranium series, the number of alpha particles emitted to reach 206 lead from 238 uranium. How many series are undergoing? See, that is 1, 2, 3, 4, 5, 6, 7, 8. So that is about mass number decreased by 238 to 206, that is 32. Each alpha particle undergoes, your question is related to the alpha, so that is about the 32 by 4, that is nothing but 8. Radioisotopes are used in carbon dating, smoke detectors, tracing chemicals. Radiotype isotopes have wide application due to their detectable radiation. Carbon 14 for dating and amidium 241 is about the detector various isotopes. The curve of binding energy per nucleon shows a peak where what? Medium elements like medium mass elements like iron which is about 56. The binding energy. Control nuclear fusion reaction used in Iran, Israel, Korea. They have nuclear power plant. In India, only one city which is run by 24/7 electricity, that is Bombay, because of the nuclear power plant station. Control nuclear fission is used in nuclear power plant. In nuclear reactor, the fission chain reaction is controlled using moderators to control sorry using moderators and controllers. That is about the frequency range of visible light in electromagnetic spectrum. You can see here gamma, X, UV visible. So here this is about. So the frequency range is 4 into 10 to the power of 14 Hz to range roughly. It is a range from 7.5, 0.4 to 0.7 or 4 into 10 to the power of 14 Hz to 7.5 10 to the power of 14 Hz. So this is about, you have to check this value, not other value. 0.10 to the power of 14 to 10 to the power of 14. So 4 into 10 to the power of 14 to 7.5 10 to the power of 14 Hz. 49. Anode rays consist of positive ions. Anode rays are stream of positively charged ions formed when electrons collide with the residual gas atoms in discharge tube. Which model is first proposed to dense central nucleus? So that is about Rutherford. Rutherford Goldfield experiment led to the nuclear model of the atom with a tiny, dense and positively charged nucleus. 51. Species the same number of electrons but different nuclear charge. That is about isoelectronic. Ionizing power is highest for, that is about alpha rays. Alpha particles being heavy and doubly charged interact strongly with matter cause maximum ionization. Beta decay, the mass number is increased, mass number in beta decay, the mass number is remain constant, only atomic number increased by +1. Coming to 54, artificial transmutation. Transmutation means converting one element into another element form. One element to another element form, which is discovered by Rutherford. He tried on nitrogen is converted to oxygen. Okay, Ernest Rutherford. Artificial transmutation was first achieved by Rutherford. Ernest Rutherford achieved the first artificial nuclear transmutation in 1919 by bombarding nitrogen with the alpha particle. Then alpha nitrogen is converted into oxygen. Here, one element is converted to the another in artificial form. Nitrogen is changed to oxygen. This is called artificial transmutation. Carbon-14 is used for archaeological dating. Carbon-14 is a radioactive isotope with a half-life time 5730 years. It is used in radiocarbon dating to determine age of ancient organic materials up to 50 years because living organisms maintain a constant ratio of carbon-14 until their death. 56. One. Energy released in nuclear reaction is of the order, that is about million electron volt. Nuclear reactions involve changes in nuclear binding energy, which is typically in the range of millions of electron volt. This is about millions times larger than energy in chemical reaction. Chemical reaction just electron volt. The sun's energy is produced by fusion of hydrogen. Sun produces energy through nuclear fusion of hydrogen nuclei into helium. So that is 58. Which ray is not affected by magnetic field? So that is obviously gamma rays not deflected by electric field. 59. The wavelength of gamma rays is the order of what? As we know, wavelength is very short for the gamma ray, maximum for the radio wave. So that is about, we can see here, less than 10 to the power of minus 12. Less than 10 to the power of minus 12. Gamma rays have extremely short wavelength, typically less than 10 to the power of minus 12, and correspondingly they have high energy and frequency. Coming to 60, which scientist discovered neutron? So that is about James Chadwick. James Chadwick discovered neutron in 1932. He observed neutron radiation produced by beryllium was bombarded with alpha particle which knocked out proton from paraffin wax. 61. Both postulates of stationary orbit violates, that is about why it is failed, that is classical electromagnetism. According to the classical electromagnetic theory, any accelerating charged particle like electron in circular orbit must continuously radiate energy and spiral into the nucleus by making atom unstable. Both stationary orbit contradicts this classical prediction. See, according to the classical electromagnetic theory, any accelerating charged particle like electron in circular orbit must continuously radiate energy and spiral into nucleus. But here he proposed stationary orbit. So that is the reason it was failed. 1s2, helium-24 are examples of what? Sorry, it is 1s3. So here you can take 3 minus 1, 2, 4 minus 2, 2. So they have the number of neutrons. So that is about isotons. 1s3, helium-24, they have same number of neutrons. So that is the reason they are known as isotons. 63. The range of alpha particle in air, that is about few centimeters. It is shorter one. So that is 63. Few centimeters. Alpha particles are helium nuclei, heavy and doubly charged. They have high ionizing power, lose kinetic energy rapidly through frequent collision with the air molecule, limiting their range to only few centimeters in air. In radioactive series, emission of one alpha and one beta particle results. So one alpha, one particle. Already we discussed here. One alpha, one particle. Okay, we have element X, A, Z. So one alpha. So now A minus, Z minus 2, A minus 4. Next beta, Z plus 1. Already we done this one, I think so. A minus 4. Okay, that is isotope of parent, isobar of parent, isotone of parent, new element with change in, new element change in atomic number. This is right. Here minus 2, here plus 1. So change in atomic number. So that is option D. Okay, sir. Now question. Okay, alpha decay decreases atomic number by 2, mass number by 4, beta increase by plus 1, so that the net effect is decreases by 1 in new element. Radioisotopes are used in industry for what? Detecting leaks in pipelines, measuring thickness in sheets, sterilizing food, all above. Yes, of course they are. So radioisotopes serve as a tracer, detect leaks by flowing radiation. For non-contact thickness gauging based on observation. For food irradiation, killing microbes to increase shelf-life. 66. The packing fraction is related to what? Packing fraction is related to stability of the nuclei. It is related to the stability of nucleus, mass defect, binding energy. Packing fraction is nothing but actual isotopic mass minus mass number by total mass. It is directly connected to the mass defect, binding energy. Uncontrolled nuclear fission leads to, that is, atomic bombing. In atomic bomb, a super critical mass of fissionable material triggers an uncontrolled chain reaction. Neutrons multiply rapidly, releasing enormous energy in fraction of second. 66. The velocity of all electromagnetic radiations in vacuum, that is about 3 into 10 to the power of 8. All electromagnetic waves from radio waves to gamma rays travel at the same constant speed 3 into 10 to the power of 8 meter per second in vacuum. It is independent of their frequency and wavelength. Positive rays were discovered by anode ray, that is discovered by Goldstein. Egan Goldstein discovered positive rays in 1886. 1832, that is about neutron. Using a discharge tube with perforated cathode, the rays consist of positive, that is about proton. Goldstein. Which atomic model introduced continuous orbit? That is about Bohr. Niels Bohr in 1913 model introduced stationary orbit with quantized angular momentum. Mv equal to nh by 2 pi by explaining the stability of atoms and discrete hydrogen spectral lines. 71. Species with same number of neutrons but different protons are called, this repeated number of times, that is about the isotopes. 72. Which radiation causes maximum biological damage per unit energy? So that is about alpha. That is about alpha. Why? Internally absorbed alpha particles have very high linear energy transfer. They deposit all their energy over very short distance, causing dense ionization and causes severe damage to cells and DNA. So that is about alpha. The law of radioactive decay states that rate of decay is proportional to number of undecayed nuclei. Radioactive decay is first order process governed by dN by dt equal to n. dN by dt is proportional to n. Remove the proportionality in opposite manner. dN by dt equal to minus lambda n. So where decay rate is directly proportional to number of undecayed radioactive nuclei present at an instant. 74. The first artificial nuclear reaction was, that is about when nitrogen bombarded with alpha, it gives oxygen. So that is by Rutherford. That is A. Nitrogen, alpha, oxygen. In 1919, Ernest Rutherford achieved the first artificial transmutation by bombarding nitrogen with alpha particle, producing oxygen and a proton. Last question, 75th. The main reason for energy release in both fission and fusion, that is about increasing binding energy per nucleon, decreasing in mass, conversion of mass into energy according to E equal to mc square. So all are right. Both processes move the product nuclei closer to the peak of the binding energy per nucleon curve near 56 atomic mass number iron. The resulting mass defect is converted into energy via Einstein's mass energy equivalence.